Greetings to you. We trust that you are doing well by the grace of God. This is Mr. Tauzeni back again to our mathematics revision class. You are welcome. We are particularly paying attention to Euclidean geometry. One theorem for now. We are doing Euclidean geometry. One theorem which says a line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. In terms of examinations, this theorem applies to grade 11 mathematics and also grade 12 mathematics. So it is vital for both grade 12 and grade 11. The line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. The most important part of this theorem that you must make sure you are clear about is that for this theorem to work, the condition is that the line is coming from the center of the circle. It's not just a line, it is particularly a line that is coming from the center, and the line is going to the midpoint of a chord. So it is the center of the circle connected to the midpoint of the chord. Then the line that is coming from the center and the chord are perpendicular to each other. The proof for this theorem is examinable for both grade 11s and also grade 12s. It's important to know how to prove this theorem. You don't have to memorize it, but just learn it enough in such a way that you can explain it to someone else, or you can do the proof on your own. Then you know you understand. So the first one is we have to draw the radius. Given that AM is equal to MB, our information that we have here is indicating to us that there is a chord that has been divided into two equal parts, and O is the center of the circle. The line dividing the chord into two equal parts is coming from the center, and we want to show that OM is perpendicular to AB. There is a 90-degree angle between the two lines. So to start with, you connect you draw A, O, and OB, which is the radius of the circle. You draw the radius of the circle. You draw the radius of the circle, the one I've indicated in blue here. Now at point M, there are two angles. It might be of convenience to us to label them 1 and 2. Then we have M1 and we have M2. After that, identify two triangles that are congruent to each other and prove that the two triangles are indeed congruent to each other. The choice of our triangles is not a difficult one. We can start from point O to the left and point O to the right. So if we start from point O going to the left, our triangle is going to be OAM. Then from O to the right, from O to the left, it's OAM. From O to the right, it's OBM. OAM and OBM. Then we need to prove that those two triangles are congruent to each other. So to do the proof, the line from O to A and the line from O to B, those two lines are equal to each other because they are representing the same measurement, which is the radius. So we wrote radii, which is the plural for radius. Then the second one, we compare the second letter to the third one, which is AM, and then the second letter to the third one in the next triangle, AM and BM. We check in our diagram to see if those two are equal or not. AM equals to BM, and the reason for that one is that it is given. Then you check the outside ones, OM and OM. OM is the same line that is being shared by both triangles. So OM is shared. You can write OM is common, or you can write OM is equal to OM, and the reason is common. Then we have three items now that indicate that our triangles have got three equal sides. So we make a conclusion that therefore triangle OAM is congruent to triangle OBM. Now we need to indicate that the angle at point M is equal to 90 degrees. We have labeled M1 and M2. Now notice something. The meaning of congruence is that all angles are equal to each other and all sides are equal to each other. So the first letter and the first letter in the next triangle, they have the same size. The angle in the first letter to the angle in the first letter of the first triangle, which means the vertex at O in the first triangle and the vertex at O in the next triangle, the angles that are there are exactly the same. The second letter to the second letter and the third letter to the third letter. We are going to compare the angles in the third letter because that is where M is. And we notice that M1 is equal to M2. Now, if M1 is equal to M2, we know from our studies of geometry that if you add M1 plus M2, the total must be 180 degrees because they are angles on a straight line. So if M1 is equal to M2, but M1 plus M2 is equal to 90 degrees, then it follows that one angle is equal to 90. And 90 degrees means the two lines OM and AB are perpendicular to each other. This is the proof of the theorem. So in general, we are expecting something like 5 marks to do this proof in an examination. Then your proof is done. All right. Let's have a look at application. Application is when you are given an examination question and you need to answer it using the theorem. Line from center drawn to midpoint of chord is perpendicular to the chord. So for us to be able to do to apply the theorem, we need some understanding of previous geometric concepts that we did in the past. The first one is that the radius is the same. You can draw the line from the center to any part of the circumference. That measurement is always the same because it is the radius. Then secondly, we need to remember that since the line from the center is perpendicular to the chord, the line from the center to the midpoint of a chord is perpendicular. Perpendicular means we have an angle that is 90 degrees. Now if we connect the radius to the circumference where the chord starts, we create a right angled triangle. And that right angle triangle will give us another idea. In a right angled triangle, we can apply the theorem of Pythagoras. Apart from the theorem of Pythagoras, we can apply trigonometric ratios of right angles. So we have trigonometric ratios of right angles and we have the theorem of Pythagoras. If you are given two sides and you want to determine the third one, then we apply the theorem of Pythagoras. If you are given one side and one angle, or you are given two sides and you want to find the angles, then we apply trigonometric ratios of right angles. So whenever theorem of Pythagoras is needed, it can only be in a right angled triangle. And in this case, we are working with right angled triangles. That is the background information we need for us to be able to answer questions correctly that come from this theorem. So in this diagram here, the line from O to B, the line from O to A, and the line from O to D, they are all equal to each other because they are representing the same measurement, which is a complex thing, but it needs practiced. I'm just gonna go back to the question I was doing now. It needs a certain measure of practice. So this is the question. We have simplified the value of CD in said form. That's theorem number one. What is the theorem again? It says line drawn from center to midpoint of chord is perpendicular to the chord. That is what you need. So never mind this one here, right? Let me just go to another question. There is another question, and all these questions are in your past examination papers. So I'm just showing you how the questions are similar, but they just try and structure them slightly different from each other. Remember, most questions are not repeated that much. So what is repeated are the ideas and the concepts that inform the answers. Right, this is another question. Maybe you may want to pause the video here and answer the question yourself and check your answer when you're done to see if you are doing it correctly or not. In the diagram below, O is the center of the circle, chord AB is perpendicular to diameter CD, AB is perpendicular, perpendicular, perpendicular. That perpendicular is telling you that the chord AB is divided into two equal parts. So AM is equal to MB. Then we have got a ratio here, CM to MD equals to 4 to 9, and AB is equal to 24 units. Now, what is our question here? Determine an expression for DC in terms of x if CM equals to 4x. That's what we are told. This is our question. So what do we do now? Here, for us to be able to figure out the answer, we need that part. The chord AB is perpendicular. That means the chord is divided into two parts because the line from center drawn to midpoint of chord is perpendicular to the chord. Then AB is equal to 24 centimeters. Dividing it by 2 will give us 12 centimeters in the chord. What else do we need? The ratio. CM equals to MD. So here that is DM, and that one there is 9 units, and that one is CM, which is equal to 4 units. So we have got 4 units here, we have got 9 units there. That is the ratio CM to MD. Now, number 10.1 is saying CM is equal to 4x. If that is equal to 4x, then we come here to CM where we have 4. That is now 4x. If this one is 4x, then it means DM will equal to 9x. Then the value of DC from D to C is going to be 9x plus 4x, which is equal to 13x. That is my answer for the first question. Then what else do I need? I need to find OM. From O to M. Now, important here, notice that DC is the diameter of the circle. From point D up to C, that is the diameter. So the diameter divided by 2 will give us the radius, which is from O up to C. So you divide the diameter by 2. The diameter is 13x. So dividing 13x by 2 will give us 13x over 2, which is the value of OC, the radius. Now, part of OC is already given. It's equal to 4x. It would mean that the value of OM is going to be OC minus MC. OC is 13x and MC is 4x. So 13 over 2. 13 over 2x minus 4x. And then you simplify, that will give you the value of OM. So there is another one that we may need to answer from this diagram. What is, it says hence or otherwise, what is the value of the radius? So our numbers that we have done so far, that we have used, is that we have got those measurements, and it becomes easier because we need theorem of Pythagoras. We need to isolate certain numbers. From the previous calculations, DC is equal to 13, and then OM 4m is equal to 2.5x, we can apply the theorem of Pythagoras in a right-angled triangle. So in the right-angled triangle, we apply the theorem of Pythagoras. That will lead you to the answer that is required for this question. That is our theorem 1. Line drawn from center, drawn to midpoint of chord, is perpendicular to the chord. So there are a number of questions here that you can want to try. Some are a little bit challenging, some are not, and this one is one of them actually that you can have a look at. It's a very cute and so nice. When I'm looking at it, I can see that is why I chose to have it here, because it is a very nice question that you can also have a look at. So once again, the theorem that says line from center drawn to midpoint chord is perpendicular to the chord. That is the theorem. One, we need two things about the theorem. We need to know how to prove it. We need to know how to apply it. I'm gonna leave you with this question. Please let me know how you think. Just to try it. It's a very nice one and a little bit tricky geometry question. If you get it right, I'll be very much happy. If you don't get it right, contact me. I will gladly send you the answer and the explanation on how to get to the answer. That is when you are done doing it. So that's our theorem for today. We will meet you up in the next video where we discuss the other theorems about geometry. So for now, it's a goodbye. Thank you very much for watching. Please remember to like and share this video. Subscribe if you have not done so. We will continue to support you as far as possible. If you need anything, any resource, any worksheet in the maths that has got notes and explanations and exam questions, you are very much welcome to contact me using the numbers that are showing there, 073 244 2000. Thank you very much and God bless you.